Have you ever looked at these enormous power lines and wondered, why do they carry hundreds of thousands of volts? If our homes only need 120 or 230 volts, why doesn't the power company simply send electricity at that voltage from the power plant? Wouldn't that be simpler? The answer involves one of the smartest engineering solutions ever developed, one that saves billions of dollars every year and makes modern civilization possible. In this video, we're going to follow electricity from the moment it's generated until it reaches your home and discover why power companies intentionally use extremely high voltages. By the end, you'll never look at power lines the same way again. Where electricity begins. Every journey starts at a power plant, whether it's powered by coal, natural gas, nuclear energy, hydroelectric dams, or even wind turbines. The goal is the same: spin a giant generator. Inside the generator, magnets rotate around coils of wire, converting mechanical energy into electrical energy. But here's something surprising. The electricity produced by these generators isn't hundreds of thousands of volts. It's typically somewhere between 11,000 and 25,000 volts. That's already dangerous, but it's still far too low for transporting electricity over long distances. Imagine trying to deliver electricity from a power station hundreds of kilometers away. Something would go terribly wrong. And the culprit is something every wire has: resistance. The hidden enemy: resistance. Even copper, one of the best electrical conductors on Earth, isn't perfect. Whenever electric current flows through a wire, some energy is lost as heat. It's exactly the same principle that makes an electric heater warm up. The wire itself begins wasting energy. Now imagine electricity traveling hundreds of kilometers through transmission lines. If too much current flows, enormous amounts of energy are lost before reaching homes and businesses. This isn't just inefficient, it's expensive. The wires heat up, they waste electricity, and power plants must generate even more energy just to make up for those losses. So engineers faced a huge challenge. How do you move enormous amounts of electrical power without wasting it? The answer wasn't bigger wires. It was something much smarter. The secret: raise the voltage. Here's the key idea. Electrical power depends on two things: voltage and current. What if we used household voltage? Let's imagine a different world. Suppose we tried sending electricity across an entire country using just 230 volts. The current would become enormous. The transmission cables would heat up dramatically. Huge amounts of electricity would disappear as wasted heat. The cables would need to be incredibly thick. The amazing device that makes it possible. But how do we increase the voltage? The answer is one of the most elegant inventions in electrical engineering: the transformer. Near every power plant, transformers raise the voltage from around 20,000 volts to hundreds of thousands of volts. The electricity then travels across the country through high-voltage transmission lines. When it reaches cities, other transformers reduce the voltage, first to regional distribution levels, then to neighborhood distribution, and finally, down to the safe voltage used inside your home. Without transformers, modern electrical grids simply wouldn't exist. Power poles would have to support much heavier wires. Construction costs would skyrocket, and electricity would become far more expensive for everyone. Instead of solving the problem by making wires larger, engineers solved it by increasing the voltage. It's a far cheaper and far more efficient solution. If you increase the voltage, you can decrease the current while delivering exactly the same amount of power. Imagine delivering water. You can move the same amount of water using either a huge river moving slowly or a narrow pipe with much higher pressure. Electricity behaves in a similar way. Instead of sending enormous current through the wires, engineers increase the voltage dramatically. Less current means dramatically less energy lost as heat. This single idea completely transformed electrical power systems. Today, transmission lines commonly operate at 132,000 volts, 220,000 volts, 400,000 volts, and in some countries, more than 765,000 volts. Those enormous voltages aren't used because homes need them. They're used because the power lines do. So why do power lines use such high voltage? Because high voltage allows electricity to travel across huge distances with minimal energy loss. By reducing the current, engineers can prevent overheating, lower costs, and make the electrical grid more efficient. Thanks for watching, and don't forget to subscribe for more fascinating explanations behind the technology that powers our world.